The engines powering the Diamond DA42 and the DA62 are the most advanced piston engine in GA right now, the Austro AE300 and the AE330. That's what drags these planes around the sky. And in my opinion, the DA42 and the DA62 are the most sorted, least drama piston airplane you can write a check for at the moment. But the road to this nearly spelt the end of Diamond aircraft. To better understand what I mean, we need to roll back a bit and look at the bigger picture. General aviation likes to think it moves slowly and safely, changing things one service bulletin at a time, making small adjustments instead of big jumps. But every so often, a manufacturer tries to drag the whole ecosystem forward in one big step instead of doing what everyone else is doing. That's exactly what Diamond did when they bet their future on diesel twins. And for a few years, that single decision came very close to killing the company. You see, the legacy engines, your Lycoming and Continental mills, are easy to mock as 1960s tractor engines, but they work, and everybody knows the numbers on them already. Fuel flows, overhaul costs, failure rates, and all the weird noises they make on hot days. Mechanics know how to keep them alive, parts are on the shelf, resale values are tied to those names, and operators would rather live with a known headache than bring an unknown one onto the flight line. That's why when the time comes to write a check for an engine, everybody runs back to those brands. So for all their sins, the dinosaurs do their job. That's why every new engine proposal has to punch through enormous inertia. It's not just conservative buyers. The whole ecosystem is welded to the old hardware. Meanwhile, down on the ground, the car world has quietly sprinted ahead. Modern automotive diesels and gasoline engines are running insane duty cycles in delivery vans, taxis, and highway commuters, racking up thousands of hours at high load with barely a hiccup. They have FADEC as standard, individual cylinder knock control, self-diagnostics, emission systems that would make a 1960s IO something blush, and they're built in volumes GA can't even pretend to match. That leaves you with a split reality. In the air, we're still babying big-bore air-cooled engines like it's 1973, while on the ground, rental cars with 200,000 miles on the clock are idling away in airport queues without anyone thinking twice. The technology gap is obvious. The real question is whether any of that automotive goodness can actually survive once you bolt it to an airplane and ask it to live at high power, high altitude, and aviation-style duty cycles. Back in 2002 at the Berlin Air Show, Diamond decided to run that gauntlet. They rolled out the DA42 and broke one of the unwritten rules of airplane design. Don't hang an untried engine on an untried airframe. If the airframe has bugs, you can usually fix them and keep flying. If the engine has bugs, you've just built a very expensive glider. If both are new at the same time, you don't get a gentle learning curve. You get compounding risk, grounded fleets, and very angry customers who wants your head on a spike. To be fair, the DA42's airframe wasn't a total leap into the dark. It borrowed heavily from the DA40, but it was still a new twin with a new mission. The real wild card was the engine, the Thielert 1.7 Centurion, built around the Mercedes-Benz OM668 diesel used in the A-Class. Millions of those engines were running around Europe, backed by millions of euros in development. On paper, it was everything the Lyco-Conti crowd wasn't. Dual overhead cams, 4 valves per cylinder, turbocharging, common rail injection, full electronic control. If you were tired of mixture levers and primer pumps, this looked like the future. Thielert did their best to distance themselves from the car engine stigma. Officially, the Centurion wasn't a car engine at all, and they claimed roughly half the parts were unique Thielert hardware, some of it there purely to shave weight and adapt the core to airplane use. But whatever the branding said, it was still an automotive-based diesel trying to live in the aviation world. At first, the gamble looked smart. The DA42 was a hit with flight schools who needed multi-engine trainers for the airline pipeline. That part is important. These airplanes weren't toys for owner pilots who might fly 70 hours a year. They were business tools. A twin that sipped Jet A, started like a car, and had simple engine handling on the flight deck was a very attractive spreadsheet. In the air, the DA42 behaved itself. It never lived up to the aspirational 200-knot marketing numbers, but it flew nicely, and the engines were smooth and easy to manage. From the left seat, it felt like somebody had finally dragged the light twin into the 21st century. Then the trouble started. By 2007, owners were running into serious AOG issues. There were reports of cracked cylinder heads, lubrication pump failures, and more than 20 documented engine stoppages. The real anchor was the gearbox. On these diesel adaptations, you're not just hanging an engine on the mount, you're trusting a reduction drive to survive aviation loads and aviation schedules. If the gearbox inspection interval is short, the labor is heavy, the parts are scarce, or the procedure is ugly, you don't just pay more, you lose airplanes off the line, and downtime is what kills operators. The Thielert gearbox needed to come off for inspection every 300 hours, and the real-world labor it took bore little resemblance to the optimistic numbers in the brochure. Owners expected the interval to move out quickly as experience built, and Thielert did promise that, but the promised extensions arrived years late. By the time the support picture should have been stabilizing, the company was in bankruptcy. Technically, the core engine wasn't some hopeless disaster. A lot of the issues could have been worked through as normal teething pains. What actually failed was the business. Overpromised performance, undercooked warranty support, poor economics, and an AOG response that couldn't keep up with the reality of a busy training fleet. For the people who'd written checks, the distinction between technical success and business failure was academic. Their airplanes were down. And this is where Diamond almost went over the cliff. DA42 customers didn't care how the supply chain was structured. They saw Diamond on the tail and expected Diamond to make the problem go away. So the airframer found itself squeezed from both sides, operators demanding immediate fixes, and an engine supplier collapsing right at the point where the fleet needed the most support. That is how a supplier problem turns into an existential company problem. There was a real possibility that Diamond could be dragged under by someone else's engine failure. Christian Dries, Diamond's founder, didn't take that lying down. The situation made him angry enough that he did something airframers almost never do. He started his own engine company. That's where Austro comes from. And that wasn't a branding exercise. Deciding to build engines meant taking responsibility for everything Thielert had fumbled. Certification, supply chain, warranty, service training, spare stocking, documentation, and a global support footprint. It was full vertical integration, not because it looked good in a brochure, but because the alternative was watching Diamond's airframe business get held hostage again. Austro's whole strategy was basically let Mercedes do the engine, we'll do the airplane side. Mercedes had already spent a fortune making the OM640 reliable in the car world, so Diamond wasn't about to out-Mercedes on the core. So they basically took the OM640, pulled off the car junk, bolted on a proper gearbox and aircraft systems, certified the package. Only later, once the program had momentum, did Austro start bringing more of the core manufacturing in-house. But the philosophy never changed. Don't reinvent the block if it already works. Engineer the interface to the airplane, and then stand behind it in the field. There was, however, a big problem on the spec sheet. Austro kept the original cast iron block. That meant the engine came in roughly 112 pounds heavier than the earlier Thielert version, and weight is a serious problem in aviation. A typical airframer would look at those numbers and say, "Come back when it's lighter." Christian Dries didn't have that luxury. Diamond's long-term strategy depended on diesel, so instead of waiting for the mythical perfect lightweight engine, he moved the airplane. Diamond spent the money and did the work to certify both the single and the twin at higher maximum weights so they could legally carry the heavier engines without destroying the payload and range story. That meant repeating structural analysis, adjusting margins, running certification programs, and accepting more risk and expense in the short term so the fleet would make sense in the long term. It's one of the key Diamond-only moves in the whole saga. They reshaped the airframes around the engine reality, instead of demanding the engine magically fit the old envelope. In the real world, that decision paid off. The Austro-powered DA40 NG shows a modest range edge over its avgas sibling, and the fuel story is quietly powerful because in the real world, Jet A is cheaper than avgas, and Jet A is the fuel you can count on finding anywhere in the world. So the diesel value proposition isn't just save a few dollars an hour. It's build your airplane around the fuel that actually exists everywhere you want to operate. The DA62's AE330 is the uprated version of the same engine family that powers the DA42 NG and the DA42-6. The DA42's variant is the 168 horsepower AE300, while the DA62 runs the AE330, which makes 180 horsepower for takeoff and 171 continuous. Both the AE300 share the same 2-liter OM640 core, the same basic Austro E4 architecture, and the same dry weight on the spec sheet. Diamond didn't go shopping for a different engine for the big twin. They took the same car-derived diesel, turned the wick up, and wrapped it in a larger airframe. On paper, this is exactly the thing everyone in GA said wouldn't work: a car-based diesel sitting at high power for long periods in an airplane. In service, these engines do exactly that. They sit around 70% power for hours at a time, with a published life limit now out to 1,800 hours. They burn Jet A at fuel flows that make a DA42 or DA62 look more like a fast single than the thirsty twins we grew up with. None of that was guaranteed. The only reason this engine family exists in production form is because Diamond almost got wiped out when the first diesel supplier, Thielert, couldn't support the DA42 fleet. The AE300 and AE330 are the second attempt at the same basic idea. If you want a simple way of understanding why Austro worked where Thielert didn't, think of 3 things that all had to line up around this engine family. First, commitment and funding. Diamond and Austro had to keep writing checks through Thielert's collapse, through standing up a new engine company, through certification of the AE300 and AE330, through raising the certified maximum weights of the DA40, DA42, and DA62 to carry a heavier cast iron block, and through extending the life limits as real-world data came in. Second, a real operational advantage. The engines had to give lower specific fuel burn than the avgas engines they replaced. Run on Jet A. You can buy almost anywhere, even where avgas is scarce or $10 a gallon. Deliver twin-engine fuel flows that sit in the same ballpark as a fast single, offer simple single-lever engine management, easier cold-soak starts, and cleaner engine-out handling that makes sense in a training environment. Third, support and warranty. There had to be gearboxes, injectors, ECUs, and pumps on the shelf, clear maintenance data, predictable cost of life-limited parts, fast AOG response, and a factory that accepts that if an Austro quits, it's their problem to solve, not the operator's. Most new engine projects in GA manage 1 or 2 of those at best. Thielert had genuine technology and a fuel burn story, but the economics and support never caught up. Plenty of other efforts had funding and enthusiasm, but no real step change in what the engine delivered, so the market just kept buying Lycomings and Continentals. Very few programs managed to hold all 3 together long enough to get out of the early adopter phase and into thousands of engines and millions of flight hours. Diamond, through Austro, forced all 3 to overlap around this one car-derived 2-liter core because they had no choice. They weren't just an airframer dabbling in diesel. They owned the airframes. They had airline academies and mission operators depending on DA42s and DA62s. And their survival depended on solving the engine problem once and for all. On paper, the solution shouldn't have worked as well as it does. The cast iron block is heavy. The engine is complex and expensive to manufacture. The market had already been burned by Thielert. There were plenty of smart people inside and outside Diamond who looked at those numbers and that history and said, this is a non-starter. So that's it for today's video. Don't forget to like, subscribe, and ring that notification bell. It goes a long way for us.